What if I told you that right now, as you listen to this, a machine built by human hands nearly half a century ago is still alive, still talking to us, and is farther away than anything humanity has ever created? What if I told you that it is no longer just exploring planets, no longer orbiting the sun, but is leaving our home entirely, stepping out into the great, terrifying ocean of interstellar space? What you are about to hear will shock you, because this is the story of Voyager, the farthest traveler humanity has ever known. The dawn of Voyager. It all began in the 1970s, a world very different from today. The Cold War divided nations. Technology was primitive. Computers filled entire rooms, yet had less power than the cheapest smartphone in your pocket today. And yet, amidst all of this, scientists at NASA had a dream. They looked at the alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune. A rare event, one that would not happen again for 176 years. They realized, if we launch at just the right time, we can use the gravity of each giant planet as a slingshot, flinging a spacecraft further and further, all the way to the edge of the solar system and beyond. This idea was insane. It sounded impossible. But it was exactly this bold vision that gave birth to the Voyager program. 2 identical spacecraft were built, Voyager 1 and Voyager 2. Their mission was simple in writing, but monumental in scope: explore the outer planets, send back data, and if possible, keep going into the deep unknown. The launch. In the late summer of 1977, the world watched. On August 20th, Voyager 2 launched first. Then, on September 5th, Voyager 1 followed. No one knew then that Voyager 1 would become the true record breaker. The fastest, the farthest, the survivor. But even in those first moments, people could feel the weight of history. It was as if humanity had built not just a machine, but a messenger, a message to the universe itself. We are here, we exist, we are reaching for the stars. The journey begins. At first, Voyager's mission was planetary. It raced toward Jupiter, then Saturn, capturing images no one had ever seen in such clarity. Giant storms, volcanic activity, mysterious moons. We'll get to that later in this story. But even as it achieved those triumphs, something else was happening. Voyager was being hurled faster and faster out of the solar system. Gravity was working like a cosmic slingshot. Every encounter gave it more speed. And soon, Voyager left the planets behind. The mission expanded. The goal shifted. Now, it was no longer just about exploration. Now, it was about survival and distance. A whisper across the stars. Here's the shocking truth. Voyager still talks to us. But how? Its radio transmitter is weaker than a refrigerator light bulb. Just 20 watts of power. And yet, across billions of kilometers, NASA's deep space network, giant antennas spread across the world, still hears it. Imagine standing in New York, whispering softly, and someone in Tokyo hearing your words perfectly. That is what Voyager is doing right now. And here's the part that will blow your mind. When Voyager sends a signal, it doesn't arrive instantly. It travels at the speed of light, the fastest speed in the universe. And yet, it takes 22 hours for that signal to reach Earth. another 22 hours for Earth to send a reply back. That means every time NASA talks to Voyager, it's like having a conversation with someone who answers you 2 days later. Distance beyond imagination. So, just how far is Voyager today? Let's put it in perspective. The distance between Earth and the Sun is about 150 million kilometers. Astronomers call this one astronomical unit, or O. Voyager 1 is over 160 O away. That's 24 billion kilometers. To grasp this, consider if you drove a car at highway speed, say 100 kilometers per hour, it would take you 28,000 years to reach Voyager. Yes, 28,000 years. And yet, our little spacecraft is still racing further every second. Every hour, it adds another 55,000 kilometers between itself and Earth. By the time you finish watching this video, it will have traveled another 500,000 kilometers away. Humanity's longest bridge. Why does this matter? Why care about a tiny probe drifting in the dark? Because Voyager is more than just a machine. It is the longest bridge humanity has ever built. A bridge from our tiny, fragile planet to the endless night of interstellar space. Every time its faint signal reaches us, it is a reminder. We are capable of greatness. We can reach beyond what we know. We can step into the infinite. Carl Sagan once said, "The Voyagers are the first emissaries of humankind to the stars." And he was right. Voyager carries with it not just instruments and cameras. It carries our story, our music, our voices, our, Boring said, our dreams. And that brings us to something sensational. Something you may not know. Something that will change the way you think about this mission forever. Because NASA didn't just send a machine into space. They sent a message to aliens. Yes, a golden record etched with the story of Earth itself. Music, ate, pictures, greetings in 55 languages. Cross. Even the sound of a mother kissing her child. A cosmic bottle floating in the infinite ocean, waiting for someone or something to find it. And in the next part, you will hear the shocking truth about what is on that record, why it was chosen, and how it could one day be humanity's introduction to the universe. What you are about to discover in the next chapter is not just science. It is art, philosophy, and hope. The Golden Record, humanity's eternal time capsule, a message to the stars. And trust me, you will not believe what we put on it. If I told you that right now, speeding silently through the dark ocean of space is not just a machine, but a message meant for strangers we have never met, a message for minds we cannot even imagine. What if I told you that this tiny golden disc might one day be the first thing another civilization knows about humanity? What you are about to hear is not science fiction. It is real. And the truth about what we placed on this record will shock you. The idea of a cosmic message. The year was 1977. Voyager was preparing to launch. The engineers had already worked miracles, designing spacecraft that could last for decades. But then the question arose. If these spacecraft might survive longer than humanity itself, should we leave behind a message? It was Carl Sagan, the astronomer and dreamer, who led the idea. He gathered a small team: artists, scientists, musicians, linguists. Their mission: to create the greatest time capsule ever made. A portrait of Earth, etched onto a golden phonograph record. Not for us. Not for now. Us. But for the future. And for whoever might find Voyager, perhaps millions of years from today. The sounds of Earth. What did they put on the record? Prepare to be amazed. Because this is not just data. It is the heartbeat of humanity. First, they recorded greetings in 55 languages, ancient and modern. From Sumerian, the language of the first known civilization, to English, Spanish, Russian, Chinese, and yes, even Ukrainian. A simple phrase. Hello, we are thinking of you. We come in friendship. Next, they added the sounds of Earth. And this is where it gets emotional. The sound of wind. The sound of rain. The crack of thunder. The song of birds. The laughter of a baby. Even the sound of a mother's kiss. Think about that. Across billions of kilometers, drifting into eternity, Voyager carries the sound of human love, the music of the world. But it didn't stop there. They included music, classical masterpieces, Beethoven, Mozart, Bach, tribal songs from Africa, native chants from Australia, the haunting melody of Japanese shakuhachi flute, Peruvian panpipes, and then something unexpected. A piece of American rock and roll. Chuck Berry's Johnny B. Good. When someone on the committee complained, saying, "Do we really want aliens to hear rock music?" Carl Sagan replied with a smile, "There are a lot of teenagers on Earth." This mix of music became a universal message. We are many. We are diverse. We are human. The pictures of our planet. But Voyager's record was not just sound. It also contained images encoded in analog format. 117 photographs. What did they show? A newborn baby. A school classroom. The Great Wall of China. The DNA double helix. Animals. Elephants, whales, snakes, dolphins, human anatomy, with diagrams of how our bodies work. Even a supermarket full of food. Yes, aliens might one day see what a human grocery store looks like. They wanted to show not only who we are, but what our planet is like. A world filled with beauty, complexity, and life. The secret love story on the record. Now here's a shocking detail that few people know. Among the sounds placed on the record was the brainwave activity of a young woman named Anne Druyan. She was Carl Sagan's colleague. For 1 hour, she lay quietly as scientists recorded her neural patterns. What was she thinking about during that recording? She later confessed she had just fallen in love with Carl Sagan. So within the grooves of that golden disk, encoded into brainwaves, is the feeling of human love, recorded forever, drifting through space. Yes, Voyager carries the electrical echo of a human heart in love. A bottle in the cosmic ocean. Think about this. Billions of years from now, long after Earth has changed, after civilizations have risen and fallen, after even the stars themselves have burned out, Voyager may still drift on. And if another civilization finds it, what will they think? They will not just see a machine. They will see our greetings. Hear our music. Feel our emotions. And they will discover that on a tiny blue planet, orbiting a small yellow star, there once lived a species that dreamed of reaching the stars. The golden record is in many ways our immortality. The controversy? Of course, not everyone agreed at the time. Some scientists said, why waste space with music? Why not put more instruments on board? Others worried, what if dangerous aliens find this and come to conquer Earth? But Carl Sagan's answer silenced them. The universe is vast. If there are civilizations out there, they already know we exist. But now, at least, they will know who we are. It wasn't about fear. It was about hope. The eternal time capsule. Today, the golden records are still safe, still attached to the Voyagers. Gold does not rust. It does not decay. In fact, scientists believe the records could survive for 1 billion years. That means even if humanity destroys itself, even if Earth one day falls silent, there will still be 2 small golden disks carrying our story through the stars. 2 cosmic bottles drifting in an infinite ocean, waiting to be found. And yet, the golden record is not the end of Voyager's story, because the spacecraft themselves did more than just carry our message. They changed our understanding of the solar system forever. They discovered volcanoes on moons, oceans under ice, storms larger than Earth itself. And what you're about to hear next will shock you, because the Voyagers did not just leave Earth. They revealed secrets of the universe we had never imagined. What if I told you that for the first time in history, a machine built by humans has left the cradle of our solar system? What if I told you that Voyager has stepped into a place no living creature, no human-made object has ever gone before, the great abyss between the stars? What you are about to hear will shock you, because this is the story of Voyager's leap into interstellar space. The edge of the sun's influence. Our solar system is not infinite. The sun's gravity stretches far, yes. But there's another invisible boundary, one most people don't think about. The heliosphere. Imagine a giant bubble, inflated by the solar wind. Streams of charged particles constantly blowing out from the sun. This bubble protects us, shields us from cosmic radiation, and defines the territory of our star. At the edge of that bubble is the heliopause. Beyond it, interstellar space, a realm where the sun's influence ends and the galaxy itself begins. For decades, Voyager's mission controllers wondered, will we ever reach it? Will our little probe survive long enough to cross that line? The journey to the boundary. By the 2000s, Voyager 1 had already passed beyond Pluto. It was traveling through the outer heliosphere, where the solar wind slows, collides with galactic particles, and creates turbulence. The spacecraft's instruments began detecting strange signs. Cosmic rays were increasing. The density of plasma around it was changing. It was as if Voyager was approaching a stormy coastline, the waves of the sun crashing into the ocean of interstellar space. And then, in 2012, something happened that stunned the scientific world. The shocking moment. On August 25th, 2012, Voyager 1 crossed the heliopause. For the first time in human history, something we built was outside the solar system. How did we know? Voyager's sensors showed a dramatic spike in galactic cosmic rays, high-energy particles from deep space. At the same time, the solar wind vanished. It was like stepping out of a warm room into the freezing night. One NASA scientist described it this way: it's like leaving your home for the very last time and realizing the air you breathe is no longer familiar. A new realm. So what is interstellar space really like? Not empty, as many imagine. It is filled with thin plasma, with high-energy particles that drift between stars. It's quieter, darker, harsher. Temperatures close to absolute zero. Radiation that would kill any living being. And there, in this vast wilderness, Voyager continues to sail. Think about it. This tiny probe, launched when Jimmy Carter was president, when the first Star Wars movie had just premiered, is now floating between the stars. If that doesn't give you chills, nothing will. Still speaking from the void. And here's the most mind-blowing part. Even interstellar space, Voyager is still sending us data. Every few months, NASA receives readings of plasma density, cosmic radiation, and magnetic fields. Each signal is weaker than a whisper, yet it arrives across 24 billion kilometers. The Deep Space Network antennas stretch their giant dishes toward the void, waiting, and eventually, a faint heartbeat comes back. It's the farthest communication link humanity has ever maintained. Voyager 2 joins the journey. Voyager 1 was the first to cross into interstellar space. But in 2018, its twin, Voyager 2, followed. The data matched. Both probes confirmed the same truth. We had left the solar system. For the first time, we were no longer bound to our star's bubble. Humanity had become interstellar. The symbolic meaning. Think about the symbolism of that moment. For billions of years, life on Earth had never left the cradle of the sun's warmth. And then, one day, a tiny probe, smaller than a car, weaker than a light bulb, broke free. It was not a person. It was not a living creature. But it was ours. A piece of humanity, carrying our story, sailing where no one had ever gone. As Carl Sagan once said, "The Voyagers are not just machines. They are the ships of the imagination, the road ahead." Where is Voyager going now? Voyager 1 is heading toward the constellation Ophiuchus. In about 40,000 years, it will pass within 1.6 light-years of a star called Gliese 445. Voyager 2 is heading in a different direction toward Sagittarius. Both will continue their silent journeys for billions of years. And here's the haunting thought. Long after Earth has changed, long after our cities crumble and our species evolves or disappears, the Voyagers will still be out there, sailing through the dark. Cliffhanger ending. And yet, this is only part of the story, because even before they reached interstellar space, the Voyagers made discoveries that shook science to its core. They found volcanoes on alien moons, hidden oceans beneath ice. What if I told you that a machine launched in 1977, before the internet, before smartphones, before most people alive today were even born, is still alive? What if I told you that for 47 years, through the cold, through radiation, through the infinite dangers of deep space, Voyager has survived? What you are about to hear will shock you, because this is the story of how Voyager still whispers to us after nearly half a century. Built to last, but not forever. When engineers designed Voyager, they never imagined it would last this long. The mission was expected to last only about 5 years, just long enough to reach Jupiter and Saturn. That's it. But here we are, nearly 5 decades later, and the spacecraft is still alive. Still sending data. Oh, actually didn't. Still traveling further than anything humanity has ever built. How is this possible? How can a machine older than most of us still function in the harshest environment imaginable? The answer lies in brilliant engineering, clever problem solving, and a little bit of luck. The beating heart, nuclear power. Most spacecraft run on solar panels. But solar power fades as you travel away from the sun. By the time you reach Jupiter, the sun is a faint dot in the sky. Voyager needed something different. Something that could survive in the darkness. So engineers gave it RTGs, radioisotope thermoelectric generators. Inside, pellets of plutonium-238 slowly decay, releasing heat. That heat is converted into electricity. At launch, Voyager produced about 470 watts, enough to power a small household appliance. Today, after 47 years, that power has dropped to just about 250 watts. That's less than 2 light bulbs. And yet, it's still enough to keep Voyager alive. But here's the shocking truth. The power drops every year. Which means NASA has to make heartbreaking choices. The sacrifices. Imagine running a spaceship like a survival game. Every year, you lose more energy. Every year, you must decide what stays on, what must die. Over the decades, NASA engineers have turned off instruments one by one. Cameras shut down. CU eaters turned off. Some instruments have been sleeping for decades. And here's the most unbelievable part. Some of those instruments still work when reactivated, despite being frozen in space for 30 years. It's like turning on an old car after it sat in a frozen field for 3 decades, and it roars back to life. The ancient brain. Now, let's talk about Voyager's computer. Remember, this spacecraft was built in the 1970s. Its computer has less memory than a digital watch. Less than 70 kilobytes of storage. And yet, it navigates, manages power, stores data, and communicates across billions of kilometers. NASA scientists joke, you probably have more processing power in your toaster. And yet, Voyager's tiny brain is still sharp, still awake, still fighting. The longest phone call in history. But surviving isn't just about power. It's about communication. Voyager's antenna is about 3.7 meters wide. It must be pointed perfectly at Earth to send signals. A tiny misalignment and the signal would vanish forever. And yet, through decades of tumbling, drifting, and cosmic radiation, the antenna is still aimed almost perfectly at Earth. Every day, Voyager sends us data, a stream of zeros and ones, weaker than a whisper. It takes 22 hours to arrive. NASA receives it, decodes it, and suddenly, the farthest traveler speaks again. The near-death moments. Voyager's survival wasn't guaranteed. Over 47 years, there were many near-death moments. In the 1990s, its tape recorder jammed. Engineers, using commands typed on ancient keyboards, managed to fix it from billions of kilometers away. In 2022, Voyager 1 sent back garbled data. Scientists feared its computer had failed. Weeks later, they discovered a memory glitch and reprogrammed it remotely. Yes, they hatched a 1970s spacecraft from 24 billion kilometers away. Every time Voyager seemed doomed, humanity pulled it back from the edge, frozen in space. And here's the chilling part. Literally, Voyager's heaters have been shut down for years to save power. Some instruments now sit in temperatures colder than Pluto's surface, colder than liquid nitrogen. And yet, some of them still work, against all odds. One NASA engineer said, "It's like watching a 100-year-old man run a marathon and win. Borrowed time. But we must face the truth. Voyager cannot live forever. Its nuclear fuel is decaying. By the early 2030s, the power will drop so low that even its transmitter will die. One by one, its instruments will fall silent, until all that remains is a cold, silent traveler drifting in eternal darkness. And when that moment comes, humanity will lose its farthest voice. Immortality? Through legacy? True legacy. But even when Voyager stops speaking, it will not be dead. Because Voyager is immortal in another way. Its golden record will last for 1 billion years. Its name will live forever in history books. Its journey will never end. Long after we are gone, Voyager will still be sailing. Still carrying our story. Still waiting to be discovered. And yet, before its final silence, Voyager gave us something priceless. Not just survival, not just endurance, but revelations. What revelations? It saw things no human had ever seen before. Volcanoes erupting on distant moons. Hidden oceans beneath ice. Storms larger than Earth itself. In the next part, you will hear the sensational discoveries of Voyager. Discoveries so shocking that they changed our understanding of the solar system forever. What if I told you that two small spacecraft, launched in the 1970s with less computing power than your phone's calculator, made discoveries that rewrote science? What if I told you that Voyager saw storms bigger than Earth, oceans hidden beneath ice, and even volcanoes erupting on alien worlds? What you are about to hear will shock you, because the Voyagers revealed a solar system more alive, more violent, and more mysterious than anyone had ever imagined. The Grand Tour begins. Voyager's original mission was called the Grand Tour. Using gravity assists, the spacecraft would visit the outer planets, Jupiter, Saturn, Uranus, and Neptune. No human eyes had ever seen these worlds up close. They were distant, blurry dots in telescopes. Scientists thought they knew what to expect. They were wrong. The Voyagers didn't just take pictures. They uncovered secrets. Shocking, breathtaking, even terrifying. That giant of storms, Jupiter. First stop, Jupiter. As Voyager 1 approached in 1979, its cameras zoomed in on the giant planet, and suddenly, the blurry red spot became crystal clear. The Great Red Spot, a storm larger than Earth, was revealed in detail. Not static, but raging, swirling, alive. A hurricane that has lasted for centuries, its winds moving faster than any on Earth. But that wasn't the only shock. Voyager discovered Jupiter's atmosphere was filled with chaotic storms, lightning flashes, and turbulent bands. It wasn't just a gas giant. It was a world of violent weather. And then came the real surprise. Io, the world of fire. See? That city machine and the world of fire. Voyager turned its cameras toward Jupiter's moons. Most scientists expected lifeless, frozen rocks. But Io, one of Jupiter's moons, stunned the world. Voyager saw volcanoes erupting. Yes, active volcanoes spewing lava into space, larger than anything on Earth. It was the first time we had ever discovered active volcanoes beyond our planet. One scientist shouted in disbelief, "This changes everything." Io wasn't dead. It was alive with fire, shaped by Jupiter's immense gravity, pulling and stretching its core. Imagine a moon more volcanically active than Earth itself. Europa, the hidden ocean. But even more shocking was another moon. Europa. Voyager's images showed a smooth, icy surface, crisscrossed with cracks. It looked like shattered glass floating on a black sea. Scientists began to suspect something incredible. Beneath Europa's ice might be a liquid ocean. An ocean larger than all of Earth's oceans combined. Think about that. A hidden sea beneath miles of ice, kept warm by tidal heating. And where there is water, there might be life. Voyager didn't prove it, but it gave us the first clues. And today, Europa is one of the top targets in the search for extraterrestrial life. Saturn? The world of rings? After Jupiter, the Voyagers traveled to Saturn. Saturn's rings had been seen through telescopes for centuries. But Voyager revealed them in astonishing detail. Instead of solid bands, the rings were made of countless particles, ice, dust, rock, forming structures more complex than anyone imagined. Some rings had braids and twists. Some had mysterious gaps, carved by small shepherd moons. Saturn was not just beautiful. It was dynamic, alive, sculpted by hidden forces. Titan, the mysterious moon. As Voyager also revealed the secrets of Titan, Saturn's largest moon. Its cameras could barely see through Titan's thick orange haze. But instruments detected something tantalizing, a dense atmosphere rich in organic molecules. It was the first moon we discovered with an atmosphere thicker than Earth's. And scientists began to whisper, could Titan hold lakes, rivers, or seas of liquid hydrocarbons? Decades later, we confirmed it, thanks to Cassini and Huygens' missions. But Voyager was the first to hint at Titan's alien landscapes, Uranus and Neptune, the forgotten giants. Voyager 2, unlike its twin, continued its grand tour. It is still the only spacecraft to visit Uranus and Neptune. In 1986, it flew past Uranus. The planet appeared bland, pale blue. But Voyager discovered something astonishing. Uranus's magnetic field was tilted almost sideways, unlike any other planet. A magnetic mystery scientists still struggle to explain. Then, in 1989, Voyager 2 reached Neptune. And here came another shock. Voyager saw the Great Dark Spot, a massive storm, rivaling Jupiter's red spot, raging across Neptune's atmosphere. Winds there blew faster than anywhere in the solar system, over 2,000 kilometers per hour. And on Neptune's moon, Triton, Voyager found geysers, jets of nitrogen gas, erupting from beneath the icy surface. Another world, another sign of hidden activity. The pale blue dot. But perhaps the most emotional discovery of all came not from the planets, but from Voyager's look back at Earth. In 1990, after passing Neptune, Voyager 1 turned its camera around for one final picture. From 6 billion kilometers away, Earth appeared as a tiny speck of light, less than a pixel. A fragile blue dot in the vast darkness. Carl Sagan described it best. That's here. That's home. That's us. Every human being who ever lived out their lives on that dot. Think of the rivers of blood spilled by generals and emperors so that in glory and triumph. That image, the pale blue dot, changed how humanity sees itself. Not as rulers, but as tiny travelers in an endless cosmos. The Voyagers showed us a solar system alive with storms, volcanoes, oceans, and mystery. But their greatest challenge was not discovery. It was survival. Because every year, their power fades. Every year, another instrument shuts down. And soon, the Voyagers will fall silent forever. In the next part, you will hear the shocking truth about the approaching end of their mission, and what happens when humanity's farthest voice goes quiet. What if I told you that humanity's farthest voice in the cosmos is fading? What if I told you that the Voyagers, after nearly 5 decades of survival, are running out of power? And soon, they will fall silent forever. What you are about to hear will shock you. Because this is the story of the Voyager's final chapter, the slow, inevitable end of their voices across the stars. The fading heart. Voyager is alive thanks to one thing, its RTGs, radioisotope thermoelectric generators. At launch in 1977, they were full of plutonium-238, glowing with heat. That heat was converted into electricity, powering cameras, instruments, and the radio antenna. But every year, the plutonium decays. Every year, the power drops by about 4 watts. In 1977, Voyager had 470 watts. Today, it has barely half of that, enough to keep only the most essential instruments alive. NASA engineers compare it to keeping a dying fire alive, moving the last glowing embers to keep just enough warmth for survival. The hard choices. Over the decades, NASA has faced heartbreaking decisions. The cameras were turned off long ago, after the pale blue dot photo in 1990. Voyager will never take another picture. The heaters were shut down, leaving instruments to freeze in the darkness of space. One by one, detectors, sensors, and experiments have gone dark. Every shutdown feels like saying goodbye to a piece of Voyager's. But it had to be done, to keep even the smallest heartbeat alive. The power budget. Today, the spacecraft operates like a hospital patient on life support. NASA must decide which instruments to keep running, balancing every watt of electricity. It is a delicate dance. Turn off too much and you lose science. Keep too much on, and the spacecraft dies faster. So engineers carefully ration power, like a family in winter, deciding which lights to keep on, which rooms to leave in the dark. Near death in 2022. House. And sometimes, even with all this care, things go wrong. In 2022, Voyager 1 suddenly began sending back nonsense data. Its computer seemed to be failing. Panic spread at NASA. Was this the end? But then, engineers discovered something astonishing. A glitch had caused the spacecraft to send its data through the wrong system. They reprogrammed it across 24 billion kilometers. And just like that, Voyager came back. Imagine that, fixing a 1970s spacecraft from farther away than the edge of the solar system, colder than ice. With its heaters off, Voyager's instruments are exposed to freezing space. Temperatures drop to 200 degrees C or lower. Electronics become brittle. Metal contracts. And yet, many instruments still function. It is a miracle of engineering. A machine built in an era of disco music and typewriters, still alive in the most hostile environment imaginable. One NASA engineer put it simply, "It's like watching your 100-year-old grandfather run a marathon and win the final countdown. But time cannot be stopped." NASA predicts that by the early 2030s, Voyager's power will be gone. First, instruments will shut down completely. Then, the transmitter itself will die. The last signal will leave Voyager, travel for 22 hours, and then reach Earth. After that, silence. No more heartbeat. No more data. No more voice. The farthest messenger of humanity will still be out there, but alone, forever. The legacy of silence. When that moment comes, it will be bittersweet. Yes, we will mourn the loss of Clark. But Voyager's mission will not truly end. Because silence does not mean death. The spacecraft will continue its endless journey, drifting through the galaxy for billions of years. Its golden record will still be attached. Its message will still exist. In a way, Voyager will become humanity's eternal ghost, a silent traveler, carrying our story long after we are gone. And yet, even as the Voyagers face their silence, their journey is not truly over. Because in truth, their greatest chapter is still ahead. The billion-year voyage through the galaxy. What will happen to Voyager when the last watt of power fades? Where will it go in the far future? And what if, one day, someone finds it? In the final part, you will hear the astonishing truth about Voyager's eternal destiny, the story of a spacecraft that may outlive humanity itself. What if I told you that long after the Earth has fallen silent, long after our cities have crumbled, and even the sun has burned out, two small spacecraft will still be traveling? What if I told you that Voyager may be humanity's only voice in the universe, drifting for billions of years, carrying our story across the stars? What you are about to hear will shock you, because this is the story of Voyager's eternal journey beyond the solar system. Right now, Voyager 1 is more than 24 billion kilometers away. It has left the protective bubble of the heliosphere and is sailing through interstellar space. Its twin, Voyager 2, is not far behind. Both probes are on trajectories that will never bring them back. They are gone. Forever. Ever. But their journey is only beginning. The time scale. In 40,000 years, Voyager 1 will pass near a small star called Gliese 445 in the constellation Camelopardalis. Think about that. 40,000 years. Longer than the entire span of human civilization. By then, everything we know today would be ancient history. And yet, Voyager will still be moving. Silent, steady, eternal. In 300,000 years, it will pass within a few light years of another star. In a billion years, it will still be orbiting the center of the Milky Way, just as stars do. No other creation of humanity can claim such a destiny. The Golden Record's immortality. Attached to each Voyager is the Golden Record. Made of copper, plated in gold, designed to last a billion years in space. Protected against cosmic radiation, against time, against silence. On those discs are greetings in 55 languages. Music from across Earth. Pictures of our planet, our people, our science, even the brainwaves of a woman in love. If Voyager survives, this record could be the last trace of humanity long after we are gone. Imagine, billions of years in the future, when Earth may no longer exist, when the sun is a cold ember, a traveler from another civilization could stumble upon Voyager. They would place the record on a turntable, and across the void, across eternity, they would hear our voices, our music, our laughter, our story, a silent ambassador. Voyager may soon stop talking to us. Its power is fading, and within a decade, its voice will go silent. But silence is not the end, because silence is still motion. Silence is still presence. Even without power, even without communication, Voyager will remain an ambassador, drifting endlessly, carrying our story like a cosmic bottle in an infinite ocean. Carl Sagan once said, "The spacecraft will be encountered, and the record played only if there are advanced spacefaring civilizations in interstellar space." But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet, the scale of Voyager's legacy. Let's put this in perspective. The pyramids of Egypt are 4,500 years old. Voyager will last hundreds of thousands of times longer. Dinosaurs ruled the Earth for 160 million years. Voyager could drift through space for longer than that. Even stars themselves live for billions of years. And yet, Voyager may outlast some of them. It is humanity's most durable creation. What Voyager means to us. Voyager is not just a spacecraft. It is a symbol. It proves that even a fragile species, living on a small blue dot, can reach beyond its home. It proves that we are capable of thinking, not in years, but in millennia, not in nations, but in species, not in planets, but in galaxies. Voyager is our first step into eternity. The poetic truth: one day, humanity may disappear. One day, Earth may be gone. But Voyager will still be traveling. It will still be carrying our story, our dreams, our hopes. Perhaps no one will ever find it. Perhaps it will drift forever, a silent ghost ship. But even then, it matters. Because Voyager is proof that we existed, that we dreamed, that we reached for the stars. So now, as you listen to this, know the truth. Humanity's farthest traveler is still on its way. It may already be silent. It may one day be forgotten. But for billions of years, long after we are gone, Voyager will continue its eternal journey. A message in a bottle, drifting through the infinite night. And maybe, just maybe, one day someone will find it, and they will know that once upon a time on a pale blue dot, there lived a species called humans, and they dreamed of the stars.